Hi everyone, let's implement the Kafka Stream service now. This time I start with a base Spring Boot project. As we already learned most of the initial steps, it's better to focus on the Kafka streams in this lecture. You can download this base project on the lecture definition. But again, if we quickly summarize what we have in this base project, first let's check the POM.xml file. You know most of the dependencies from previous sections. But note the three new dependencies: Kafka Streams, Kafka Client, and Kafka Streams Avro Serde. As we always do, edit the versions to the base POM.xml file. We have the similar logback file as was in the previous services. We just updated the properties with the Kafka Stream service application name. We left application YAML file as empty, as we will create a config file in config server for this new service. In Bootstrap file, we set the application name and the profile. And as we know, we need to have a config server properties file that ends with this profile, Kafka_streams. Here under Kafka Stream service prefix, we set the custom audience. We will create an endpoint in this service to allow to query computed stream data, so we set the port as 8187 and also set the context path as Kafka Stream service. Also set the OAuth resource server issue URI and GW key set URI, as we want to secure this service also with OAuth. And again, since we will have an API, we set the Spring Doc configuration similar to the Elastic Query service and edit the API docs path to ignore list. Also edit retry config, since we will use the Kafka admin client where we need retry configuration, and we added Kafka config to get Bootstrap servers and schema server information, and finally edit a new config, Kafka Streams config, which includes a unique application ID necessary for a Kafka Stream application, input and output Kafka topic names to be used in streaming data, a state file location and store name to store the state of compilation we done and use it to return with an endpoint. For Kafka Streams service and Kafka Streams config prefixes, we need to create two new config data classes in app config data module. We will use these classes to mesh this configuration into our Java code. Here in the Spring Boot starter class, we have a command line runner, as was in the Twitter to Kafka service, which was our first microservice if you remember. There were a similar logic to first initialize a Kafka topic and then start Twitter stream runner. Here we do almost the same. First check if required topics created in stream initializer and then start the Kafka streaming logic. Here is the initializer implementation where we used Kafka admin client to check if topics created and also check schema server is up and running. For stream runner we don't have an implementation yet. We will write it together shortly, as this is the new part on this microservice. Before, let's check the other classes that are already added to this project. Here we have a constants class again. Then in security package, we have similar files as was in query service. Audience validator checks the correct audience in GWT. Kafka Streams user defines the authentication user with username and granted authorities as properties. And Kafka Streams user details service overrides the load user by username method, which is called when a user authenticates. This time, we simply use the authenticated username to construct the authentication object. Remember that we used a database call to fetch the document permissions in query service, but here we don't need that. And again, Kafka Streams user GWT converter is actually the same GWT converter of Elastic Query service to construct the user authorities from GWT claims. I won't go over those classes in detail as we discussed them in query service. You may think that we could use shared classes for this GWT converter or audience validator, as they are almost the same. You may try that, however, keeping those classes specific to each service will be safer, because this way we can easily change the security implementation in each service separately. Otherwise, we could create a single dependency that would cause to change other services unexpectedly. And finally, web security config. Again, the same of query service one. Only the injected user details implementation class is different. However, for the same reason, I will keep this config also in each service separately to keep things simple. Great, we went over the base project. We can now continue by adding the streaming part in the next section.